All right, we're going to do a couple more problems with interpreting change in exponential models with manipulation. So we have this formula right here. One thing you need to be able to interpret that this is your A value and this is your B value. So right now, what is my B value equal to? It's equal to a factor of 8. Now here's what it means, okay? It means that every single second, what's happening? This relationship, everything's being multiplied by an 8. So right now, this is our factor. Well, what do we want it to change it to? We want to change it not to a factor of 8, but to a factor of 2. No, where the B is. You got to change it from an 8 to a 2. I'm going to N of t equals 1,000. Our A value stays the same. What do we want our B value to be? We want it to be a, no, we want it to be a 2. But wait a second. 2 to what power is equal to 8? 3. You're right.
Oh, 3? I'm don't call yourself stupid.
Especially when we're recording on YouTube. It's not okay. We shouldn't do that. You should feel good. Remember, you're good enough, you're smart enough, and doggone it, people like you. Okay? So, 2 to the power of 3 times t. We just manipulated the formula. Okay? All y'all are pretty good at manipulation. Alright? So hopefully you'll understand how to manipulate the formula to be able to get it from a factor of 8 to a factor of 2. Now, it says the number of bacteria is doubled every certain amount of seconds. We just want it to double, which means 2 to the power of 1. But what do we have up here? We have a 3 times t. If I plug in a 1 right there, it's 2 to the power of 3. So I need to figure out what number, like 3 times what number equals a 1? What would t have to be? 1/3. So that's why the answer in this particular problem is 1/3. Every third of a second, it's going to double. That's why the answer is 1/3. So you had to plug in a 1/3 in order for it to be just doubling. So I'm going to go ahead and type in a third. 1 divided by 3. Okay? All right. Now we're going to go ahead and do this one, and then I will do one of yours that's on your screen. Okay? This one's a little bit different. Now we're not dealing with a factor. Look right here. What are we dealing with? We're dealing with a percentage. Okay? So right now it says complete the following sentence about the percent change in the number of bacteria every second. What is our B value right now? It's 0.81. All right? So our B value is basically 81%. What are we losing? If you're multiplying it by 0.81, you're losing 19%, not every second. Yeah, so right here, this is not every second. This is every 4 seconds. I'm trying to teach you guys how to interpret stuff. Every 4 seconds, you're losing 19% because you're multiplying it by 81%. All right, so it's only losing 19%. Okay? Well, we want to do it not every 4 seconds. We want it to be what? Every second. So here's what you're going to have to do in the calculator. You're going to have to do 0.81, but you're going to raise it to the power of 1/4 of t. Now, this is what you're going to have to do in the graphing calculator. I can't do that just in my head. Okay? So go to your graphing calculator, do 0.81. I'm going to do it in parentheses. All right, parentheses. 0.81. Close parentheses. Raised to the power of 1 divided by 4. Does everybody see that right there? Okay. So 949, which rounds into what? 0.95. So here's your new equation. I'm going to go back a page right here. write your new equation. B of t equals 6,400 parentheses 0.95 t. So every single second, what's it being multiplied by? It's being multiplied by 95%. But what does that mean? It's losing. If it's being multiplied by 95%, what are you only losing every single second? You're losing 5%. So my answer here is going to be every second there is a 5%, not adding to, but a removal from the Petri dish. So 5% is being removed. All right, so here we go. There is a 5% not addition to, but removal from. Okay? Now, I believe this is similar to your problem, I believe. Alex, is it similar to your problem? Okay. All right. Well, right now, does anybody have a problem you want me to do real quickly?
Fine.
All right. Can you write me down your function? M T 1.16 in parentheses 4t plus 3. And yours is asking for a percent. Okay, yours is dealing with a percent. It's going to be, by the way, it's going to be a percent adding. Okay, so here's how you would separate your problem. 1.16 power of 4t times 1.16 to the power of 3. Using the product property, okay? This is actually going to be my b value. This is my a value. So I'm going to write it in order now from a and b. My a value is 1.16 to the power of 3. And my b value is 1.16 to the power of 4t. In order to find my rate, I'm going to take this part right here. And then grab the calculator. I'm going to take that part. This is my a value. This is my b value. So in the calculator, I'm going to type in 1.16 to the power of 4. Press enter. It says 1.81. 1.81. Okay, so here we go. 1.81 to the power of t. So what have I done? I've changed from this to this. These mean the exact same thing. This is for this rate right here is being multiplied to the power by the power of 4. This is just the power of 1. So what percent right here is being added to? What? Oh, 81. 81% is being added every single time. That 0.81, that lets you know it's being, that's what's being added to. That's what your answer would be. 80. How did I get to 1.81? I took 1.16 to the power of 4, and that's approximately equal to 1.81. That's how I got the 81%. All right, what does yours say? P of t. What's it equal to?
2 to the power of 3t.
3t plus 7? Okay. If I wanted to rewrite it, this is how I would rewrite it. My base number is 2. I'm raising it to the power of 3t times. Base number is 2 to the power of 7. Now, this is going to be my a value. This is going to be my b value. 2 to the power of 7 is 128. That's my initial value. Okay? This right here, you didn't know that? 2 to the power of 7 is 128. That's where I got the 128. Okay? So all I did was do what? Just change this to make it my initial number. Now, all I have to do now is do what? Just do 2 to the power of what? 3. So I'm going to do 128 parentheses. That becomes 8 to the power of t. What is that factor. Now yours is not dealing with the percentages. It's saying what's the growth factor? What's it being multiplied by every single time? What's it being multiplied every single time? By a factor of 8. So your answer is literally just going to be the number 8. Okay? Yeah, it's being multiplied by a factor of 8 every single month. Check. You get it right? You got it right. Good. All right, so that's enough about that particular one. We need to go from interpreting change. We need to know how to interpret changing units. So here we go. So here's a problem right here. I'm going to do a couple of these problems. All right. Oh, good. Oh, this should be very helpful. It says, ocean sunfishes are well known for rapidly gaining a lot of weight on a diet based on jellyfish. The relationship between the elapsed time, t, and days, that's going to be important. So what's t in? Days. Since an ocean sunfish is born and its mass, the mass per day in milligrams, is modeled by the function. So what's our a value? 3.5. What's our b value? 1.05. And what does t represent? T equals days. All right? Now, it says complete the following sentence about not the daily rate, but the weekly rate. Okay? Not the daily rate, but the weekly rate. Okay? We got to figure out what is it increased by a factor of. So what's kind of the change in unit versus time? What are we going to say? Days, right? Days versus what? Weeks. How many days you got to have in order to get a week? 7 days? 1 week. Okay? So this is the daily rate. We got to figure out the weekly rate. So we're gonna do a couple of things here. All right? What if I did 1.05 to the power of 7? That's instead of 1t, right? That's 1 day, right? 1 day. What if we did like 7 days? Let's try that. 1.05 to the power of 7. So what does it look like our growth factor is? 1.41? Let's see if this works. It says rounded to what, 2 decimals? So if I go back, wait. That's it, 1.41. So we'll put 1.41. Let's see if it works in our calculator, right? Here we go. 3.5 parentheses 1.05 to the power of, after the 7th day, what should the mass be? 4.92 grams or whatever it was. Let's try this one. 3.5 open parentheses. What if I did this growth rate right there, and I raised it to the power of 1 week? This is 7 days, right? This is 1 week. If it's right, what should it equal? The same thing. So does everybody understand that this rate was not the weekly rate, that was the daily rate. This is the weekly rate. Why did I put a 7 there? To show you what the rate would be after 7 days. What did I put the 1 there? That represents what? 1 week. This represents 7 days, which is a week. So if we go back here, what am I going to write there? 1.41. Let's see if we get it right. All right. Got it right. Okay? We'll do one more of these problems as an example. All right? Cool. So you wanted to see how contagious yawning can be, since yawning's done in math all the time. To better understand this, he conducted a social experiment by yawning randomly in a large crowd. Observe how many people yawn as you do that. See, I made you yawn, didn't I? All right, good job. It was your sympathetic. The relationship between the elapsed time and, what's t this time? Minutes. Since Godfrey yawned and the number of people in the crowd, per minute, who yawned as a result modeled by the function. Complete the following sentence. About the, we got to change it from minute to what? Hourly rate. Right? People who yawn as is. So if this is the people who yawn per minute, what's our conversion that we're going to have to do this time? There are what? 60 minutes in 1 hour. The last one we did was what? 7. What was our last conversion? We did what? 7 days equals 1 week, right? So what do we think we're going to put in front of the t value right there? Put a 60, right? So we're going to do 1.03 to the power of 60. And that should help us know how many people yawned every single hour. So here we go. 1.03 to the power of 60 gets us, look at that factor, 5.89. Now we're going to check it. What do we start with? 5, right? So here we go. 5 parentheses 1.03. And there are 60 minutes in an hour, right? That means about 29 people yawn. Start with 5. And I go up here and I get my rate, 5.89. And I raise that to the power of 1. It should be the exact same. See how they're the exact same? So what's our factor? 5.89. So we go over here. And right here, I'm going to put 5.89. And I'm going to check. All right, so we're just going to go ahead and type in 5.89. And hopefully got this one right. We did.